Number 65 says, friction is providing the force needed for a car to travel around a flat circular racetrack. What is the maximum speed a car can safely travel a radius track that's this, and the coefficient of friction is this. So you don't need to do this, but I'm just going to draw the car. Here's the wheel. This is a back view, mind you. A rear view. Here's the treads. And the road is, like, I'm going to say turning to the left. So there's gravity pulling down, there's a normal force, and there's a force turning it, which is the centripetal force. So these are the three forces. I mean, there's air resistance pulling back on this, and there's the car's engine pushing forward, but I'm not going to worry about those because those cancel each other out, assuming it's going at a constant speed. So friction, the thing to know about this thing is that friction turns the car. And when friction turns the car, that's what it says. Friction is the turning force, and you find the force of friction by the coefficient times the normal, and the centripetal force is v squared over r. Now this might freak you out because it doesn't give you a mass for the car, and you're like, I don't get it because it doesn't give me a mass. But that's okay, because remember how we find the force of gravity is always just 9.8 times the mass, right? Mass m, and that's always what the normal is, 9.8 m. So let's take this and stick it in there, 9.8 m, and the coefficient. And it turns out we're gonna, whatever the mass is, 9.8 times, let's say the mass is 100. So you're gonna take it times 100, but then you're gonna have to divide by it. I mean, you're gonna have to, since the mass is on both sides, it cancels out because you're gonna, whatever you multiply by, you'll end up dividing by on the other side. So 65 says that the radius of the track is 80 meters. So the radius is 80. What's the speed you can safely do it in? And if the coefficient is 0.40. So you could make up a mass if you wanted to. You could just say, oh, the mass is 100, and just stick something in. If they don't ever give it to you, you can always, sometimes you can make it up, and it just ends up canceling itself out, and that's what it does here. So we take 9.8 times 0.4, multiply by 80, take the square root of it, and the answer comes out to be 18 meters per second. So it doesn't matter what his mass is. It turns out that it was kind of, didn't matter.